All right, let's finish these up. For I and J, you have a triple composition. That just means a little bit more work. So you do start with your innermost function, tan of negative pi force. Remember, pi force is 45 degrees. So we're being asked to find the tangent of negative 45 degrees, which a picture would be helpful. Negative 45, clockwise rotation, puts us in quadrant 4. There's negative 45. Has a reference of obviously 45. In quadrant 4, wow, I don't know what that is. In quadrant 4, so we would say tangent of negative pi force or tangent of negative 45 is no different than the tangent of 45, except for the fact you're in quadrant 4 where tangent is definitely negative in quadrant 4. So after all that, what is the opposite or what is negative tangent of 45? Well, it's negative, just negative 1. So that's square root of 2 over 2. That's sine or cosine. So this would be negative 1. So tangent of 45 is 1. Negative tangent of 45, we're talking negative 1. And that's the first part of our composition here. So what we have is sine of the cosine inverse of negative 1. All right. Again, we're looking at quadrantals here. So you say the cosine inverse of negative 1. Now, normally I say we're in Q1 if we're positive, Q2 for cosine inverse if we're negative, but we know this to be a quadrantal. So the question is, when is cosine of x equal to negative 1? Well, if you draw a picture of our cosine, we'll find out pretty quickly here. There's 2 pi. There's pi. How does cosine work? Well, we know the graph by now. If we draw this, at least what we need. Cosine inverse of negative 1 says cosine of x equals negative 1. Cosine of x equals negative 1, that would be pi, or 180 degrees, which would probably be a little bit easier to say. But I guess since we're going to go to a graph for sine, we might as well keep it as the sine of pi. And the sine of pi, quick picture. 3, 4. We don't need the entire graph. We just need up to pi here, but they're so much fun to draw. Let's just keep going. So there is sine. What is the sine of pi? The sine of pi is a 0. That's 0 degrees. That is not 0 degrees. That is just 0. Sorry. It is a ratio. All right, letter J. Start with the innermost. If you ask what is the sine inverse of negative square root of 3 over 2, well, ask yourself what sine inverse of square root of 3 over 2 is, and you will say, well, it's 60 degrees. However, it's negative, so we got to go to quadrant 4. We're looking at negative 60 degrees. So now, let's fill in the rest around it. So what we got is the cotangent inverse of tangent of negative 60 degrees. Again, quick picture, draw a negative 60 degree angle, going clockwise there. We're in quadrant 4, so what would I say about tangent of negative 60? Tangent of negative 60 is the same thing as the tangent of 60, except you're in quadrant 4, which means it will be negative. So tangent of 60 is simply the square root of 3. We're looking at negative square root of 3. Those are quadrant 4. So ultimately, this comes down to cotangent inverse of negative square root of 3. We got to do a little bit of work here again. Put it this way, cotangent of x equals negative square root of 3. Turning it into a normal trig function, not the inverse. So cotangent of x, well, that's 1 over tangent. I think I can write down here. That's 1 over tangent of x equals negative square root of 3. Take the reciprocal of both sides. That gives us the tangent of x is equal to negative 1 over the square root of 3, or something that might be a little bit more familiar to you. So tangent of x equals negative square root of 3 over 3, but let's be careful here. We have to go with Q4. Cotangent and tangent inverse both operate in Q4 when the value is negative. All right, so we have to think about a quadrant 4. Get rid of the negative. We'd be looking at 30 degrees. With the negative, go to quadrant 4, it's negative 30 or negative pi 6. Phew, that was a rough one. All right, letter K. Now something that I'd like to say about these, when you talk about a function composed with its inverse, we said something a long time ago. F of f inverse of x is equal to x. And what we have here is that situation, except that when you do the cosine inverse, you had to restrict your domain of cosine, because cosine, remember, is a wave, an infinite wave, that does not pass the horizontal line test. And if it doesn't pass the horizontal line test, that means its inverse will not be a function. So what we had to do with cosine is we had to basically restrict its domain. Now I'm just kind of making stuff up here. And we restricted it from 0 to pi. Right? So you get a piece like that, so when you did reverse the points, it does actually produce a function. Or we could say this passes the horizontal line test now. So this guy right here, that's for an unrestricted domain both ways. But if your domain is restricted, we can't just say, oh, they cancel out and you're going to get 5 pi thirds. Sometimes that happens, but unfortunately that's not always what happens. So you say, well, what do I do? Well, how about you treat this like any other problem? So let's not take shortcuts and cancel things out because a little dangerous here. We're going to start with the innermost function. I'm going to find the cosine of 5 pi thirds. Might be wise to know what 5 pi thirds is degree-wise, so I can draw this angle here, or this reference angle. So pi thirds, what I know is 60 degrees. 60 times 5 is 300. So in essence, I'm being asked to find the cosine of 300 degrees, which puts us in quadrant 4. Just as important, reference of 60. So the cosine of 300 is just like the cosine of 60, except you're in quadrant 4 where cosine is definitely positive in quadrant 4. The cosine of 60 is simply a half. So now I take that answer and find the cosine inverse of 1/2. Cosine inverse of 1/2, we go to quadrant 1. We say, well, the cosine inverse of 1/2 is simply 60 degrees. Or we probably should go back to radians here because they originally put that angle measure in radians. So we'll just say it's pi thirds as our final answer. And you can see, no, they didn't just cancel out. Even though they're inverse functions, it's not always this necessarily, because this is from a restricted domain of cosine. So we're kind of restricted in our output of cosine inverse. The range is going to be restricted for cosine inverse, and 5 pi thirds will definitely not be in that guy's range. So to make a long story short, simply handle this the same way you've been handling all the other compositions. Don't try to take shortcuts because they don't always pay off. All right, same thing here. Don't just cancel stuff out and assume it's going to work. It might, but we do have to be careful here. So best bet, just treat this like every other problem. Start with the innermost function, work your way out. So if we ask, what is the sine inverse of negative square root of 3 over 2? I would ask, what is sine inverse of square root of 3 over 2? And that answer is 60 degrees. But since there was a negative there, we go to quadrant 4 and say negative 60. And then I have to ask, what is the sine of negative 60? Well, if I draw a negative 60 degree angle, that does put me in quadrant 4, no kidding. So sine of negative 60 would be the same thing as the sine of 60, except you're in quadrant 4, and sine is definitely negative in quadrant 4. So we're looking at the opposite of 1/2, aka negative 1/2. All right. Let me check those answers real quick, make sure I didn't screw anything up. Well, I just did. I sensed something was wrong there. Sine of 60 is not negative 1/2. That's the cosine of 60. We're looking at square root of 3 over 2. I did that on purpose to see if anyone would catch that mistake. Yeah, that was bad. Sorry. Negative square root of 3 over 2 for the sine of 60. I think From there, we are good. All right.